So, welcome everyone. Tonight we will be talking about a very specific set of tasks on Android, which you will have to deal with either way on the way to become a real Android developer. You are all Android developers, of course. And this is opportunistic guaranteed deferred background execution. This is a little frightening at first, but let's go through the words to better understand what we will be dealing with. Opportunistic means that you want to run tasks with constraints, and those tasks need to be run whenever and as soon as those constraints are satisfied. Guaranteed means that these tasks will run even if the application is sent to the background or is killed or the device was restarted previously. Deferred means that when you run the task, you don't really want to see the result of it right away. You don't care about it when you schedule these tasks, but you eventually want them to run. Background means the classic definition of background. You don't want to block any. You don't want to block the UI thread. You don't necessarily want the user to see this work in the background. And that's it. That's what we will be talking about tonight. So let's just think about some tasks we can do with this method. Basically, you can do background synchronization with a server. You can download like events or images or upload images like Google Photos do. So this is what this is about. And let's think a little bit more about what we could do if we wanted to handle these tasks on our own. First of all, we would really like to schedule one-time or periodic works and handle the scheduling of them. Then we should remember the parameters passed at the time of the scheduling to retrieve them when the task is actually run. For the constraints, we should really be able to listen to system-wide state changes, like when the device the task runs on is on Wi-Fi, is connected to the internet, is not low on the battery, and so on. So we also should respect the background processing limits that were introduced and gradually evolved since API 23. And we would also want to monitor the existing scheduled works to do some computing to build some business logic on these states. Also, we would really want to cancel works which are already scheduled if they become unwanted. If a task fails and we want to get a notification or a state change event about it, then we should handle the failed works. Also, it's an absolute plus to support Coroutines and RX nowadays. So let's put all that in the box also. And of course, if we manage to build a framework this big, then we should really support testing. But of course, we don't have to do all of this because we have WorkManager to do all of this for us. So without further ado, let's get to work. To use WorkManager, you have to include at least one of these dependencies in your app modules build Gradle file. The first one is for the unfortunate souls who are needed to write Android applications in Java. So let's get on with it. The second one is for Kotlin and Coroutines. The third one is for the RX support of WorkManager, and the last one is the testing library for WorkManager. With all that behind us, let's get to actually defining a work. To define a work, you have to implement a class which inherits from worker, which in fact inherits from the listenable worker abstract class, which has the lower level implementation of the work handling logic, and we won't go into that in depth. You can check out the documentation of it. So we will call this class sync events worker. You will see why that's that way. The worker class actually needs two parameters, the context, like everything else on Android, and the worker parameters, which will be available later when the work actually gets scheduled. By implementing the worker, we only have one thing to do, to implement the doWork method to override it, and the doWork method should return a result at the end of its run. Inside of this function, everything runs on background thread by default with the default settings of WorkManager. But it has a limitation that the body of the doWork method has to run, can't run for more than 10 minutes. It's actually not well documented in the developer.android.com documentation, but well documented in the Java doc of the code. So yeah, there's a Java doc, and there is that 10-minute limit. And after that 10 minutes, if the work is still running, then the work will be signaled to stop, and it will be cancelled in the end. All right, so let's see an example of what we can do in the doWork method. This small example fetches events from a network data source, which in fact calls an API and does some network heavy work. And the result of that call gets passed to the schedule notifications function, which schedules actual Android notifications based on those events. And then we return a result.success, which is one of the ways we can return from the doWork method. The other two ways are result.retry and result.failure. Result.retry means that WorkManager will try to reschedule the work if it has failed, or result.failure means that the work will not be rescheduled, it will be left as in the failed state. Let's refactor this a little bit so we can do some error handling. From network calls, all kind of exceptions can be thrown, so we just surround our business logic with a try-catch, and everything's fine. We still return a result.success object, and if any exception occurs during our run, we just return result.retry because we really want to get those events to be scheduled. All right, so this is the basic way we can define a work. There are some extra stuff here, like coroutine support. For supporting coroutines, we only have to inherit from coroutine worker instead of the normal worker. And with this, we get the superpower of a suspending doWork function. With this, we have the opportunity to use everything we do in coroutines on the other parts of our code. We can define the dispatcher right here, right now, and we can do the context switching like we normally do with coroutines. And also, this way, the cancellation and everything around coroutines will be handled for us. WorkManager does this without us having to do anything more. There is also Rx support in WorkManager. We have to inherit from Rx worker, and instead of the doWork method, we have a createWork method here, which returns a single of result. And here's a good example of what we can do by building on the previous example. We get the events from the network data source. On success, we schedule the notifications, which we get by using single. And if everything's all right, we map the result to result.success. If some error occurs, we map the result to the result.retry. Okay, so let's get on with constraints. What we can do to constrain our works to certain situations. There are quite a few options here, so let's just quickly go through them. The first one is quite obvious. This will be true if the device is not in power saving mode, and that's it. The next one is when the device is on the charger, then this will be satisfied. The next few are the corresponding network type requirements. If you don't define any network type requirements, then the work won't be depending on any network conditions. But if you do, then that it is inferred that at least somehow the device needs to access the internet for this work to go on. Of course, that gives us some problems which we have to think of, like what if the work is already started, its constraints were met, like the device had internet with the network type.connected constraint, but during the run of the work, this constraint becomes invalid, the device loses the internet connection. Everything's okay in that case. WorkManager handles this for us and automatically reschedules our work. We don't have to do anything with that. Also, there is the set requires storage not low constraint. This is kind of a shaky thing, because this becomes true when the device reports with a notification. Maybe some of you have already met this with maybe a low-end device or something in the past. The device actively sends you not dismissible notification about the background storage being low on space. This constraint is based on that mechanism. And to go further down the line, there are some API-dependent constraints to be used. Starting with API 23, we can use the requires device idle constraint. This is based on the dose mode and the background limitation frameworks. So when those mechanisms report that the device is in idle mode, this constraint will be met. Also, starting with API 24, we have the power to set triggers on actual resources defined by a URI passed to the add content URI trigger method. By doing this, WorkManager will actively listen to the changes of this resource, and it gets notified when the resource changes. There are two additional constraints that are working with this. Is the set trigger contain max delay. This is the delay when WorkManager first sees the change of this resource it's tied to. And the set trigger content update delay is when any other changes happen. Also, all right, yeah, highlight. I completely missed the highlight. Yeah. So there is a little caveat about defining time in WorkManager and delays, because here you see the time in two parts, the actual value and the time unit. So we have another method to do this. From starting with API 26, we have the ability to use the duration API, but well, this is a little heavy on the API level. So further on, we'll just stick to the two parameter, the time definitions. Okay. The next thing is defining one-time works. Okay. So in order to define one-time works, we have to use the one-time work request builder. Yeah, everything is a builder in WorkManager. Next we have to pass it a type parameter, which will be the sync events worker we defined before. We can pass in the constraints with the set constraints method, and we can add tags to this work that will be scheduled with this work request. Also, we can give it additional tags. The tagging is a mechanism that makes works groupable. So when you want to refer to already scheduled workers, you can query these work groups by tags. Okay. Also, there is a set initial delay setting, also with this two parameter method. This is the initial delay between the work getting into the system, into WorkManager, and between the first time it gets scheduled by it. Also, there is a backoff mechanism working there. The backoff mechanism basically kicks in when a work fails due to some constraints not being met after it has already begun running. And if that happens, the WorkManager gets this algorithm, which is configurable, and reschedules the work according to this logic. But we have some influence over this, how this works. We can define a backoff policy for the backoff logic. It can be exponential or linear, and we can add the initial delay of this rescheduling, and then the linear or exponential algorithm kicks in and does the rest. We have two constants here, min backoff millis and max backoff millis. This initial time has to be between these two values. It's a little unfortunate because this is hard-coded milliseconds, and then we have the ability to define the time units. So it's a bit of a design flaw in the library. And we can also add input data to our works, which actually will be read when the work gets scheduled. And for some back reference, this was the worker params we pass into the superclass of our works. With this setInputData method, we can build a data object with a builder again, and this basically works the same as the bundle we all used to in Android. We just call typed put methods on it, and then we build it. We also have a better solution for this, a more Kotlin-y solution with the work data of method, where we can pass in pairs and then just get on with it. On the worker side, you can access this input data in the doWork method. We have the input data property, which in fact has a key value map property, which we can check if we got the required parameters for the work to run, and we can decide if we want to run the other part of the business logic by this. And we can access the actual input data, the parameters, by calling the typed gather functions on input data. Okay, we're almost there. We're also able to run our first work. So how about enqueuing one-time works? We already defined our constraints. We defined our work request. Now it's time to enqueue it. First of all, we have to get our grasp on a WorkManager instance, which in fact is a singleton instance by default. We can get it with the getInstance method. We should pass in a context, like in every other Android library, and then we can call enqueue unique work. This has a few parameters. The first is actually the unique ID of the work, which will be stored with it. And the second one is the behavior, what WorkManager will do when it senses another work with a matching name already in the running state. If there is no such work, then WorkManager will just create it normally and go on with the rest of the stuff it has to do. But if it has a conflict, then this mechanism is at play. The keep behavior is that the existing work will be left alone, and the new work which we wanted to schedule will be just thrown away. The replace behavior is that if there is a running work with the same ID, it will be replaced, stopped, cancelled, and then replaced, of course. And there is the interesting part with append. If there is already an existing work with that same ID, the new work will be created and will be added as a leaf of the existing works chain. We'll be talking about chains later on. So let's just go on. The last parameter is the request itself. Okay, now let's continue with defining periodic works. With periodic works, we want works to run like in a maintenance window, or uploading logs, or check the events every day at midnight or something. This is what periodic works are about. So let's remember a little that how the one-time work request is built. The periodic work request builder is not much different. We just have to call the periodic work request builder with our worker classes type, and then we have one or two sets of time parameters. This is the one, this is the two. The first has a minimum of 5 minutes, the second has a minimum 15 minutes, sorry, the second has a minimum of 5 minutes. And what are these? This set of parameters is the repeat interval we want the work to be run in. The repeat interval by default is measured from when we enqueue the work, and the interval's end is this much time later. We have a small influence on when the work will be run in this interval, but by default, if we only give the repeat interval to WorkManager, then the only thing what's guaranteed that it will try to run our work when the constraints are met, of course, in that time interval sometime, somehow, but we don't have the control over it when we define only these parameters. We can get a little more control over this mechanism with the flex time interval. And instead of me babbling about the flex time interval, let's just get back again to the Java doc of WorkManager, which just provides us with a nice figure, an ASCII art. So on the bottom, you can see the interval. It's the bottom line. It's the whole interval our work can be run in by WorkManager. And with flex interval, we can specify the trailing time that WorkManager will schedule our work in. So the figure is quite obvious, I hope. Okay, how to enqueue such works? We have to call the enqueue unique periodic work on WorkManager, and there is the usual thing, the name, and then the only difference here is that we have to give an existing periodic work policy, which only has two values because periodic work can't be chained, so there is no append here, but keep and replace works just the same as in one-time work requests. Okay, we are done with the heavy part. Now let's continue with monitoring our existing works which we already enqueued. When we build the work request, we automatically get an ID of it, which we can access by calling the request object's ID. And after that, we can do one of three things. We can get works by ID, by this ID, and we'll with every method we'll get a work info object, or more precisely this way a future which holds a work info object. But futures are not so good, are they? So we have live data here. WorkManager supports getting a live data of this work info that is attached to the work. So okay, the second, third things here. The work info by tag will give us all the works which have the tag that we defined, and get work infos for unique work gets us the specific work that has that unique ID. Okay, we can handle the received live data like we handle any other live data object. We give a lifecycle owner, an observer, and we do whatever we want with the work info we get. The work info has these fields: the unique ID of the work, the state the work is in, the output data which can be generated and saved by the work, the progress, which is in fact another data object. We can retrieve the tags, and we get some internal information on how many times this work was tried to run. Okay, the most important part here is the state, which we'll be using most of the time. These are all the states which work can be in. The only non-trivial part is blocked, and blocked is when the work cannot be run, but it tried to. So when a constraint is unmet while it was running. Okay, we can of course cancel works. This is fairly easy. We can cancel all works, which we should be very careful of, because this will cancel all works that are related to our application. So just handle this with care. The next one is cancel all work by tag. This is quite obvious too. We pass in a tag and all works with that tag will be cancelled. There is cancel work by ID, same thing but with IDs, and cancel unique work by a unique work name does the same thing. And here we arrived at chains. So a chain is basically works chained together and depending on each other mainly. So here we defined two work requests, yes. One is doing some downloading things like downloading images or any files. Let's go with images here. And there is a processing work which will run when those images are downloaded, and they have to be processed for whatever. So a chain can be created like this. You can start it with a begin with method, which actually accepts multiple work requests. And then you can call then as many times as you want on this Fluent API, and you can just put together a chain of works. The specialty of this is that works depending on each other will fail if their parent fails, basically. So if a chain's first work fails, then all of the chain fails, and all of the chain's works will be rescheduled with it. There's actually an article which I included in the references, which talks about just this behavior. You should really read that, but I talk about that in the references. Okay, we are nearing the end. And no talk about WorkManager can go on without this figure, which is actually the official documentation on when to use WorkManager. It asks the same things that we got answers for when we defined our problem set here, the opportunistic guaranteed deferred background execution. So yeah, there is WorkManager, and on the bottom there's WorkManager. You can see this in the official docs. I don't believe that we have to go through this one by one. And for the references, of course, there's the official documentation, which is very well written and has good quality examples. We never touched testing in this talk, but it's another topic. It's a broader topic and has many classes to know and use. But there is the official documentation with very good examples of how to use those classes. Also, there is a code lab written in Kotlin, which you can see. It it walks you through the steps and basically the same things I said before. It's quite useful, and it has a more meaningful example than we had time to touch here. Okay. Also, there are talks about Google employees, one from Google I/O 18, and there's also one which goes into more detail on the low-level stuff regarding WorkManager. It was shown on Android Dev Summit 19, and there is the article I've been talking about, when WorkManager stops working. So Dan Liu writes a few lines about how a work chain can fail if you use the append behavior, and how a work can already become failed when it's chained together with already failed works. This is a race condition that is real, by the way. Okay, so summing everything up, if you if you have to deal with opportunistic, guaranteed, deferred background execution, then you should choose WorkManager, which in fact respects background processing limits introduced in API 23 and evolving ever since. And you can configure WorkManager for all of your needs. It supports Coroutines, supports RX if your project is based on RX, and it's a very useful tool if you need to work like this. Thank you for listening, and I hope you will have a nice evening here at AutSoft. And that was me. Thank you.